Hello, and welcome to this lesson on the concepts of strength and concentration in relation to acids, alkalis, and the pH scale. In today's lesson, we will define what dilute and concentrated solutions are, exploring how these terms apply specifically to acids and alkalis. Then, we will understand how concentration differs to strength. Let's begin. So far, you've become familiar with acids, alkalis, and the pH scale. We've discussed how substances can be either acidic or basic, alkaline, and how the pH scale measures the acidity or alkalinity of a solution. This knowledge sets the stage for us to delve deeper into how the concentration of these solutions influences their properties. Let's start by defining what we mean by dilute and concentrated solutions. Imagine you are making a squash drink. If you add just a small amount of squash to a full glass of water, you get a dilute squash drink. In chemical terms, this means there is a low concentration of solute, the squash. Conversely, if you add a lot of squash to a small amount of water, you create a concentrated squash drink, meaning there is a high concentration of solute. When we talk about acids and alkalis, the solute are hydrogen ions, H+, for acids and hydroxide ions, OH- for alkalis. In a dilute acid, there are fewer H+ ions dissolved in a given volume of water. Similarly, in a dilute alkali, there are fewer OH ions. In concentrated solutions, there are more of these ions per unit volume. It's important to differentiate between the terms strong and weak, and concentrated and dilute. A strong acid, like hydrochloric acid, HCl, completely dissociates in water, releasing all its H+ ions. A weak acid, like ethanoic acid, vinegar, only partially dissociates in water. This means that not all of its molecules breaks down into ions in water. Some stay as ethanoic acid molecules. However, either type of acid can be concentrated or dilute depending on how much solute is present in a given volume of solvent. Weakness or strength is a fundamental property of the acid itself. Even if you put a gallon of vinegar with a tablespoon of water, it will still be a weak acid, just a very concentrated weak acid. Conversely, if you place only a tablespoon of hydrochloric acid in a gallon of water, you would have a very dilute, but still strong acid. This is similar for alkalis. A strong alkali, like sodium hydroxide, NaOH, completely dissociates in water to release OH ions, while a weak alkali, like ammonia, only partially dissociates. Again, both types can be in concentrated or dilute solutions, depending on the quantity of solute dissolved. Now, let's see how this relates to pH. A strong acid, such as hydrochloric acid, HCl, will have a low pH because it completely dissociates in water, providing a high concentration of H+ ions. Conversely, a weak acid like ethanoic acid will have a higher pH than a strong acid because it only partially dissociates, providing fewer H+ ions. The concentration of the acid or alkali also affects the pH. Diluting an acid decreases its concentration of hydrogen ions, making it less acidic and increasing its pH closer to neutral. A concentrated solution of a weak acid will have a lower pH than a dilute solution of the same weak acid. Likewise, a concentrated solution of a strong acid will have an even lower pH than a dilute solution of the same strong acid. Understanding the interplay between strength, concentration, and pH helps us predict the behavior of acids and bases in different scenarios, and is crucial for practical applications in chemistry. In today's lesson, we delved into the concepts of strength and concentration in relation to acids, alkalis, and the pH scale. We clarified the definitions of strong and weak, as well as concentrated and dilute, and understood an important principle. Both strong and weak acids and alkalis can be either concentrated or dilute. We then explored how strength and concentration affect pH values. This knowledge is fundamental for predicting and explaining the behavior of acids and bases in various chemical contexts.